Hello everyone, and welcome to this video also about software exploitation. So in this video, we will go over another example, which I explained last time in previous videos, that there are three different ways to exploit a process or an application. So we talked about exploiting the client using a local exploit, like a multimedia application, excuse me, by like crafting a malicious playlist and feeding it to the multimedia application, or a word processor also by feeding it a malicious, let's say, Word document. So when the word processor tries to process it, you exploit a weakness in that application. Same thing applies to a PDF reader or really any other client application. Excuse me. Then we jumped to the exploiting the application remotely. So you have a service or a process which is running and listening to some connections, like an FTP server, waiting for a connection to connect to it, and then providing it some service, or a web server running remotely, like serving web pages, or any other really network service which you can access over the network. So this is the threat actor will be sending their malicious, let's say, payload remotely. They don't need to, let's say, fool the victim or anything else. If once they find this service running and they are in direct contact with it, and when what I mean by direct contact here is that, let's say, there's no filtering, no firewall, etc., so they can communicate with the process, then they can craft their malicious payload and send it remotely and exploit that process. Now, the third one, which I left till the end, and we'll use a really good example today, and I'll explain why it's a good example in a little bit, is exploiting the client, but this time also remotely. So you might be looking at, hey, but the client is running on my computer, or it's running at the client's end. It's not running remotely. So how am I going to do that? The idea is in this case, or in this scenario, is that the client themselves will visit your like evil website. So the threat actor might craft an evil website. Once the client visits that website, if the application they are using to visit that website, which is probably a web browser, it has a weakness, then probably the threat actor will be able to exploit that weakness. Or a user has an FTP client and they want to connect to an FTP server. So the threat actor will create an evil FTP server, and once the client connects to it, they will be served with an evil payload, or with some malicious data to exploit that application. Same thing applies for any other network service or any service that you can use a client to connect to it remotely. So this time what we are doing actually is the threat actor will be serving the client with an evil service. Okay, again, the threat actor is going to be serving the client with an evil service. Now, what type of evil service? It depends on the type of application you want to target. If you are targeting an FTP server, an FTP client, then definitely it's an FTP server. If you're targeting a browser, then you might be interested in creating an evil website, and so on and so forth. Okay, so this is the example which we will be discussing today. Also, in the past couple of examples that we did, we were always looking, like, for example, for a JMP ESP or a call ESP. This time it's not going to work. So in today's example, okay, the other thing which we will learn out of this, not just the exploiting the client remotely, is there is no JMP ESP. And I on purpose picked a really good example. There is no JMP ESP, or let's say there is no jump or call to ESP. We can do that. There is also a NULL byte. How are we going to deal with that? So there's a NULL byte. There are situations similar to the one that we're going to deal with today that you will see. We can avoid the NULL byte and kind of fool the system that we are going to work around the NULL byte. And also, final thing is why a debugger is important. So this is another example which will show why a debugger is important. Okay, this is also going to show why debugger is important, and using a debugger we'll be able to see where is my data going in memory, and why would I go with this option, not this option. I'm going to do all of that. And yeah, so let's get started. The example I decided to use for this one to explain all of the ideas, like we want to explain this is one, and I also want to explain these in this single example. We won't be doing in this video anything about bad characters, so we'll try to avoid them. Just use some bad characters which I already know are bad characters. How to deal about that, we'll have another video for that, but for now let's just focus on how to get how to deal with these three cases and work on exploiting a client remotely. Okay, so let's start. So here we are going to be targeting a client called an FTP client. It has a vulnerability in the version 6.7, has a remote buffer overflow. The exploit author is Sebastian Castro. You can go check his work out. The exploit is found on ExploitDB, the same thing for the application, and you can find it under 44596. Okay, so that's the exploit that we will be using. Okay, so just make sure you install, go here to this application, install the vulnerable application. I've done this a long time ago, but I think I've never had the chance to prepare the video. I did yesterday do a video on this, but unfortunately, due to a mistake, I paused it and I forgot to unpause the video. So that's in the past now. I had to now record it again. And actually, even I had to do the session again for my students because there was no recording. So I had to do it live today, and now I'm doing it again. But hopefully that's for the good for everyone else. So just make sure you install it. I think I only have 2 days left in my trial, so hopefully we'll get to exploit it today and get rid of it and move on to another case scenario. Okay, so here is our application. Let's go to our threat actor, download the same file again. This is the one, 44596. Just download that, the code, the exploit. Okay, and let's move it to our to this directory. So if it's download on downloads 44, let's move it over here. I'm going to make a copy of it, by the way. And again, I've explained this multiple times. I like to exploit py, so it's exploit 1. Okay, and let's do yeah, let's open this using my mouse pad editor. So open, and let's see, these were from my my previous example which I did at the college. So where is my home? Is it this one? Yeah, this one. Okay, so we're going to leave all the credits for Sebastian. We will just do a couple of modifications. We don't need the buffer for now because we are starting from scratch and moving on. So I'm going to delete all of this. Okay, delete all of that and then leave all of this. I just need to add one thing here, which is about the reusability of so this exploit, if you stop it and you reuse it again, it will tell you that the port is already bound to port 21. So in order to avoid that, I think I found it. I forgot. I used to use it in the past, but this is the code to do that. Again, I haven't wrote a lot of Python code in a long time, so I'm getting, I think, a little bit rusty, maybe. So this is going to enable the reusability, let's just type it here, enable kind of reusability, yep, of the port. So port 21 will be freed. Okay, so that's what we need here. We are going to delete all of this, by the way. We are going to start from scratch. So I'm going to delete. So we know the payload size, by the way, is 400, but we're going to start from scratch. So let's just put junk. Okay, and then the junk here, I'm going to send A's of multiplied by 400. I'm going to delete all of this. We don't need them now, at least. we will gradually update our payload. Let me just go quickly over what this is doing. So this is importing the socket and the sys Python libraries, and then it will try to run this line of code. So that's why we have the try except. So it's going to try run this block of code, okay, which is actually creating a socket, and it's listening it. It's binding it to the IP 000, which means it's listening on all interfaces on port 21. So it's going to be listening on port 21, okay. And then we're going to create a queue of 5, then just display a message saying this is the port number, your like FTP started on port 21. That's what it's going to say. And then if anything fails here, we are going to get this message. So if this block fails, we will be getting this message. So that's part 1. Then we are creating the junk here, the payload which we want to send. And then here in the while loop, we have it's always true. So as long as there are payloads or packets coming in from a client, so clients connecting, we want to use the socket and accept that connection. And from that, take the address and create an object of type socket. So this is a socket object, but this will have the details of the client. So we can use it to connect back to the client. And that's why we are using it here. So con.send, it's clear that the user here, or let's say the owner of this FTP server, we can like say, welcome to my FTP server, for example. So this is going to be sent immediately to the client who's going to be connecting to our FTP server. The client will send something here. So it's most probably is going to be a username. So we are going to respond back with that your username is okay. This is the status code for that. Then the client will, since the username is okay, going to send the password. Then the server is going to respond back that your password is also okay. So these are all crafted. So it appears to the client that they are actually talking with an actual FTP server, while actually they are not. So then later on, we will receive, or the FTP server, this malicious FTP server, will receive the payload from it will receive a new, let's say, command from the client, and then what we are going to do is send 220 as a response at the payload, and then is current directory. So most probably what the client is going to be sending is the print working directory. Usually FTPs, once they log in, they will ask for the working directory that they got into. So, and that could be also, by the way, reconfigured on FTP applications. But in this case, this is what's happening. So now we have this going on. Let's see, what do we need to do? So we can start Python to exploit 1. Okay, let's do that. Password. So it's now listening on port 21. Let's go to our client and connect to our threat actor server. So the threat actor server's IP address is this. In my case, just make sure you, in your case, you know what the IP address is. So I will need to just connect to it. So 192.168.8.109. Once I hit connect, you can see we got this access violation. Let me drink some coffee. So we got this access violation, and it means there is something that happened. Let's look at the commands that we received actually. So let's look here a little bit and see what do we have over here. So if you go back, we can see this, which is the welcome to my FTP server, which the threat actor had in their code. So in their code, if you remember here, we did welcome to my FTP server. Okay. After that, the client said the user command, and then the password, the user anonymous. We responded back, said, yeah, that username is okay. Then the client sent the password, the pass command, with the password itself. And then we also responded, yeah, that's also okay. So they then sent print working directory, so PWD, and we responded, or the threat actor or the malicious server responded by 20 and all of this. So we sent back the 400 bytes of A's. As you can see, that, by the way, the application didn't really crash. It like it's still working. I think we can still use it, but it didn't succeed in doing what we wanted it to do. So let's check it in a debugger and look closer at what happened in this case. So let's close, go to our debugger, immunity. Okay, now go open. Again, I've already done this. So if you go to the path, it will be installed on C, program files, x86, FTP client, and then just go to FTP shell, because I did this today to my students. And I also actually did it yesterday when my recording failed. So let me just, by the way, modify the appearance a little bit, because I had to change this for my class. Let's do this. I think it should be good. Yeah, these should be fine. Good. The application is paused, so let's start the application and connect to our malicious FTP server again. The server is still running, right? Still running, accepting commands. So let's run again, 192.168.8.109, enter. So it crashed. Okay, it paused. It did pause, or kind of crashed, because the debugger now captured this. Now let's look at this. What do we have here? Do we have any control in the registers? So in the registers, when we look at these, in the past we were focusing mostly on ESP. So ESP now does not point to anywhere on my buffer. Like the buffer, my A's are here, so it's deep down in the on the stack. So it's not directly now, like you can see here. So it's not really pointing directly to my A's. So I no longer can, let's say, do a jump ESP. This is not going to work, or call ESP. But if we go down a little bit, so ESP is not going to work. EBP also, and currently we don't have, let's see what does we have in EBP. So EBP is also not pointing to any of my bytes. But if we look at ESI, we got the string copied into ESI. So if we follow in dump, we can see that the string was in ESI. Okay, so we controlled a register, but it's not ESP. Let's do some modification to our malicious server and run it again, see what's going to happen. So we don't have control over EIP. So let's see what's going to happen. Let's modify this. So restart and start it again. And while this is starting, I can drink coffee. Okay, start. Go back to our threat actors application, malicious server. I'm going to stop. Again, I prefer to do it this way. So what we can do now, we can change, say, this is number 2. It's up to you, but this way you will have an idea what are the changes that you did. So if we add like 1000, by the way, just let's add a number. So increase the number, see, will this overwrite EIP or not? So let's do that. No, not 1. We want to do 2. Good. Run. Again, this is running, which is good. Let's bring this a little bit down here. So go back, and we have everything ready. 192.168.8.109. Enter. What happened here? We overwrote what? EIP. So it's interesting. So what the payload which we sent now overwrote EIP. So we are able to overwrite onto EIP. So we have control over EIP. But again, the idea why I wanted to use this example is there are many things we will learn out of it. It's not just about sending a payload, overwriting EIP directly, and then taking advantage of it. In this case, it's not going to work. But let's see why it's not going to work. So EIP is overwritten. That's good, at least for now. We can see ESI is overwritten with A's, and we can see EBP is now overwritten with A's. We have 2 things overwritten with A's. But what we don't know yet is how many bytes do I need to write in order to overwrite EIP, right? We need to know the offset. So again, last time I think, or in the previous videos, we use Mona. This time let's use the Metasploit's MS pattern create. So let's restart again. Like you can see, this is a long process, trial and error. We keep doing that until we find at the end our working exploit. So now we'll need to modify this. So I'm gonna create another file, call it number 3, okay? But this time it's going to be a little bit different, and we will let's create our pattern, MSF pattern create. The length will be 1000, right? That's what we used. So let's just copy the 1000 byte and put it into our payload. So now our payload, instead of sending 1000 bytes of A's, we are going to send all this junk, which is a unique cycle. If you remember, we talked about this last time. It's a unique cycle of A's in the buffer. So let's get this started. So let's run this again. This is number 3. Yep. So 3, run again. Everything is working properly, fine. Let's go here and connect to our malicious FTP server. Connected. So we have overwritten again. We have overwritten EBP, like we saw, but with these characters, which is I'm sure they are part of our payload. We've overwritten ESI also with that, and we've overwritten EIP. So let's copy that. I'm gonna write that down because I can't really copy and paste it into my threat actor because this is running on a remote environment. So I'm gonna copy, write them down. 6E41 and 336E. Okay, I'm gonna write this down to use it and calculate the offset. Again, restart again. Let's do that. So restart. Yeah, we didn't want to restart and then start it again. Okay, run. While this is getting, let's run it. Okay. So again, close this. See, we can close it, by the way, because we had that line which I added into the code, this one, which will allow us to close and run it again. Now let's create another one, call it number 4, and do a slight modification, but based on our calculation. So we need to do MSF pattern offset this time, right? And we need to do a query. And the query is we want to ask for 6E and then 41. 6E, 41, 33, and then 6E again. So let's see. Oh, so the offset is 400 bytes. Okay, so the offset is 400 bytes. Let's get this ready, which is number 4. Not run it now until we update this. So this time, what we are going to do is we are going to delete this, put back our A's. This is multiplied by 400, right? Then we have EIP because we need 400 A's to reach EIP. So let's put the B's in there. Okay, we can do that, or you can just say B multiplied by 4. And then after that, we need to put the pad because we sent 1000 bytes. So let's just add that. This time I'm going to use a cool method instead of like calculating things manually every time. If you have math problems, like probably myself, we can use this way of doing it. So junk, calculating the junk. Actually, let me rename it now to offset even. So this is going to be offset. So I'm going to calculate the length of offset. Okay, then subtract again the length of EIP. I know it's only just 4 bytes. We could just say add those EIP, but let's make our work clean. So we have offset EIP pad. So what we are going to send here is the payload. Our payload will be also offset plus EIP plus the pad. So that's how our offset will look like. So we're going to subtract from that the length of the offset, the length of EIP, fill the rest with what? With, let's say, C's. So let's do that. Fill it with C's. And now let's run number 4 again. So if we do this, run 421. And actually, before I do that, let me do one update here. I like to do this usually for debugging purposes. The payload size is, let's do this, and then len of payload. So let's do that, and this way we can keep continuously seeing the size of our payload. So the size is 1000, which is correct, what we need. And let's go back here and connect to our evil server. So again, 192.168.8.109, connect. Good. So we did overwrite what? EIP. We managed to overwrite what? EIP. And now let's look at this, because this is one of the reasons why I chose this example, by the way. So we have overwritten EIP, and if we look at the stack, we can see the A start here, and then if we go down, 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 more, we can see this is where our the B's, which got written into EIP, and then we can see the C's come immediately after that, which looks good, right? Everything looks good here. So what are we going to do next? We can't, what are we going to do next? Let's just look at these also. We can see now that EBP actually is pointing at, so if I do follow and stack, it's pointing at the C. If I do follow and dump, we can see, again, it's pointing at the C's. Please keep this in mind. Currently, EBP is pointing at the C part, while ESI is pointing to the A part. So if you remember, if we go back to our payload, we had here 400 bytes of A's, then the EIP, then the C's. So in this example, if I draw this, by the way, MS Paint, I'm not a good designer, but give it a try. So we can see what's going on. So if we have, this is our stack, okay, right? And let's maybe do EIP over here somewhere. So this EIP, or let's do it over here, yep. And let's put just the name EIP. So EIP, just like that, so we know what we are doing. So this EIP, and then what happened is the A's, four A's, right? 4 A's, and then let's just add a filler, okay? And these are all A's also, okay? These are all A's. And then what happened here is we got the C's, right? C's, and then we have the C's. So this is how our stack actually currently is looking like. Okay, this is how currently our stack looks like. We A's and EIP and the C. So we have our ESI actually pointing to the here at the beginning, or actually the bottom, because the stack is in the other way around. And we have the C's, which are beyond EIP. So it's pointing at the other part. Okay, so just keep that in mind, because it's very important. Why? Because it means if I am gonna want to put my payload in this area, then I need to use which one? I need to use EBP, right? Because it's the payload is in the C part. If I want to put my payload in the A's, then I will need to use the ESI. Why? Because ESI is pointing to the A's. So this is really why I chose this example. And you'll see we still haven't dig more into this, but you'll see why probably if I use EBP, it's not going to be a good decision, while if I use ESI, sorry, it's going to be a good one. Why? I'm not going to tell. Let's just get into that and see it by ourselves. So let's decide to go, because at the end you are you explore the ways you will be able to exploit the application. So let's decide to go the first way, the first one, use EBP. So we are deciding to do EBP. So what we need to search for is a jump EBP or a call EBP, right? That's what we need to search for. So if I do a find and let's do jump EBP, see if we have one. So we do have one, but it has a null byte. Okay, so let's try to find maybe a call EBP, also null byte. And this is in the same application, by the way. We are using the application itself. I'm not going to use anything like we did in previous examples. This time I want to explain a different method, so that's why I'm using the same example here. So again, let's do, you can go with call EBP or call jump EBP. Both will really not make a difference because they both do the exact same thing, kind of. So let's take this address, which is call EBP. Let's put a breakpoint on it, and I'm gonna just type it, write it down, I mean, on my paper here, so I can copy it to my 6E and then 82 and then 40. Okay, so let's do that. So we are going to target our EBP by jumping to do a call to EBP. Okay, so we are gonna like send our this address into EIP, replace this with this, and try and send it and get to this code, this data over here, which are the C's. Let's restart. Okay, yes, and then start the application. More coffee. Start. And now let's let's go to our threat actor and modify the code. So let's do 5. So this is now 5. And then what we are going to do, the A's are going to stay the same. We are just going to modify this part. So this will be x0x, and it will be 40, 0x, 82, 0x, 6e, right? 0x, the 00, right? That's the null byte where we will be sending that. Okay, so now let's run this again, but close, run number 5 this time. And we have also 1000 bytes. So everything, the size of our payload is correct. Let's get our application and connect to our evil FTP server. So 192.168.8.109, enter. Look what happened. So actually what happened is we didn't jump to the EBP, the call EBP. We didn't jump there. We didn't go there. Why? Because as you can see here, we have part of that address, by the way. We can see that the 6E882 F40, I mean, but it got stuffed with this 6F from somewhere. We don't know. That got stuffed from somewhere. But let's look at the stack. Let's go up the stack and look down here. So this is where our A's came in. This is where our A's came in. All good till now. Then look at here what happened. So what happened is all of our data in our stack, it got truncated. Why? Because of the null byte. So the null byte actually caused us to lose the C's. We don't know where the C's are anymore. See, we don't. That's why we use a debugger. We can like wander around, explore what's available in the memory of this application, what's inside its head, and we can see there is no C's anymore. We lost those C's. They are probably somewhere, but we don't know, or maybe they didn't even get to the memory. We don't know. We can't see them. At least in the stack, we can't see them. We might do some search. But what happened is that null byte truncated the rest of the code. Okay, that null byte truncated the rest of the code. Let me just turn off my my phone, put it silent. So that means our call EBP will not be successful. Why? Because the call EBP or the jump EBP means if I'm going to put my payload in the C side or in the C part of my exploit, I'm going to lose it. Why? Because I no longer is going to be after the null byte, right? It's going to be after the null byte, and I don't control the area beyond the null byte. I don't control it. I can't see where those C's are. So we'll need to go back and check the other way around, which is using the ESI. Okay, so we can't do the EBP because this null byte truncated the code, and EBP was pointing to the second part of my payload. So let's go back this time, use a different method, which is to use either a jump ESI or a call to ESI. So let's start this again. Okay, start. And let's go to our FTP shell and just search for what? Call ESI. So let's do call ESI this time. And we have this address. So let's put a breakpoint here. Let me just type that down, which is 00401278. Now you'll say, hey, but this one also has a null byte. How are you going to deal with that? Now the trick here is, and this is why, again, we need a debugger, and this is why exploitation, each case should be taken differently or separately. I would say Not all cases are exactly the same. Every case has its ups and downs, and it will interact with the data we send differently. So in this case, we remember that ESI was pointing to our stack, but it was pointing to a part at the beginning which we already control. So what this means, or what I'm trying to say here, is we could probably add these bytes at the end of my payload. Okay, add these bytes at the end of my payload, and getting that stuffed into EIP, like just pushing it into EIP, okay, but without the second part of the payload. Again, what we are doing, what we're going to do here is the offset, the number of bytes here. So we are going to send these bytes, same thing, but here instead of sending all of the, let's say, let me just create a copy of this. So I will like modify this one. So what we are going to do is send, instead of all of EIP, we are just going to send 3 bytes. So the null byte, we will not send it. The application will add it itself to truncate the string. And then everything after this, actually, we will not send anything because it's not going to matter. Okay, so we're going to send A's and then 3 bytes here. 3, let me even delete this. And just write down 3 bytes of call ESI. Okay, 3 bytes from the call to ESI. That's what we are going to send. And again, what will happen is the system will automatically, or the application will add that null byte at the end, because it will need to terminate the string. So we have that here. We have everything ready. Let's get started. So we'll go back, close this. Now do number 6. Modify the code. This is going to be number 6. And this time what I'm going to do is EIP. We are going to remove the null byte, but let's also modify the whole code. So this time we have 78, and then we have 12, and then we have 40. We're not going to send the null byte. Okay. In this case, let me just take this out, and then I'm going to just send payload, offset, and EIP. We no longer need actually the pad anymore. We no longer need the pad. So I'm gonna I'm gonna leave it this way. Okay, we no longer need, because we have the 400, and then we have this, which the system will automatically actually kind of add. You can like think of it like this: system or application. Application will add the /x00, which is the null byte. Okay, so let's check this out and see if that's true or if I'm just making this up. So now let's go here. This is number 6. Run. This time the payload is 403, because 400 is our offset, and the 3 is the 3 bytes of our jump or call ESI. Before I run it, I do remember I put a breakpoint on. So this is the one we are using, call ESI, right? So let's delete this. I'm going to delete this one and delete this one. Keep and you can just like hit the delete button on your keyboard. It will delete those. So we're just going to leave this breakpoint, which is a call ESI, as you can see, this one. And let's go back to wherever we were and now connect to our malicious server, 192.168.8.109. Enter. What happened here? So look what happened here is, you can see we got to the call ESI, which is great. ESI, if we follow it in the dump, it includes our payload, which is the A's. And I know we have this instruction here, but it's not really going to matter, and we will see that. And then after that, we have the whole A's. We can see that. And then here in the stack, actually, you can see it even here. So this is where the A's end, and then we can see the address, which is 781240, and then the null byte got added automatically. Same thing here. If you go down in the stack, go down, 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 and then you can see here the 4141, it ended. Then we have the address, which is 00401278, which got pushed into EIP, and that's why now we control EIP with this partial address that we sent. If we do F7, we will jump to this area where we control, and now these are all the A's that we sent. So everything is working exactly properly as we want, right? But if we added, and you can see now why we went with the ESI case, we didn't go with the EBP case, because ESI was pointing at some area over here. And once we added that address at the end here, it truncated the code behind the address, behind the IP. If we go back to our design, the code, when we added the null byte, it truncated all of that. So I no longer control it. I don't know where it is. So that's why we had to use the ESI instead of EBP. So that's why there is first no jump ESP. We have a null byte, and why a debugger is important in exploitation. It's trial and error. I know that it takes time. I also know that, but at the end, it's fun once you get everything sorted out and you understand what you're doing. So let's restart this again and go modify our code a little bit. So all should be running, right? Good. Go back here and let's stop. This time I'm gonna do, what am I gonna do is let's change these with like knobs. So I'm gonna modify the code and add a payload maybe. So it's time to probably add a payload. So we can do, let's put this over here, and now we need the pad. So we need to do some calculations and create our payload. So let's go to a payload. Let's use this. How did I get these? Don't ask me now. You'll know later. But for now, let's just generate this payload and use it for our testing. So let's bring this a little bit up. Okay. So let me copy all of this and then we'll modify them inside our code. So go here. We are gonna modify this code with this. I'm gonna delete this line. I don't need it. Right, we don't need that. This is gonna be commented out, and we don't need any of this. I just use this way so I can remember what is the command that I used. Okay, so in this case, this is our payload. You can see the size is 220. Do we have enough space in this area to push our payload in? Now, if you are in a class with me, I will be asking you that question, but since this is just a recording, the answer is what? Let me drink some coffee. The answer is yes, we do have that. Why? Because this is 400 bytes. So this is 400, right? And we only have a payload of 200 bytes. So everything looks good. So let's go back, modify our payload. So we have this. So what I'm going to do now, I'm going to add some knobs at the beginning. So I'm going to do 16, and I'm on purpose going to do 16. You'll also see why. But let's change this X90 for the knobs. We need now, what do we need now to do? We need to put a pad, right? Because our buffer here, if we go back, our buffer, it's not 16 bytes to reach EIP, it's 400 bytes. So I need to modify this. So we have the 16 bytes. Now let's get the pad. So let's bring it over here. But this time the pad is actually 400, right? And then what I'm going to subtract from it is the knobs and also the buffer. So I'm going to subtract from that the buffer, and I'm going to replace this with also 90. So the buffer will come in here, but I'm just going to put a placeholder. So what will happen is we'll put knobs, buffer, pad, and then EIP. So if we go back here, just to understand, we'll put the buffer, the knobs. We write this down, but let's use a different color, black, for example. So if we will have here the knobs, we will have here then the buffer, which is the payload or the shellcode, shell, yeah, let's just put buffer anyway, you know what I mean. And then we'll have the pad, right? So this is pad, pad, and then pad until we reach this location, right? This is what we are doing right now. This is exactly what we are doing. So knobs, buffer, pad until we reach the ESI. So all good. Let's make sure everything is working. So the knobs, the buffer, just put as a placeholder here so you can understand. You can visualize it in your head. 400, remove 16 knobs from it, remove the buffer size, and then multiply the rest by 90. So we'll fill the rest of the buffer or the rest of the payload with, or the rest of the 400 bytes with knobs, okay? And then our EIP. So what do we need to do here is modify our payload. So now it's knobs, and then buff, right? And then pad, and then EIP at the end. So this is how, because like I wrote them, knobs, buff, pad, EIP, knobs, buff, pad, EIP. So let's now run this code, which is number 7. Good, everything is working. So let's do that. Same thing, 403, good. Go back, run our 192, 168, 8, 109, enter. We called ESI, so we stopped on our breakpoint. We are now at ESI, right? And you can see, by the way, here in the buffer, these are where our 16 knobs are. These are where our 16 knobs are. And then this is where we have the shell code. And then after the shell code comes our more buffer of knobs, more knobs. And then you can see this is where we had our call ESI, which got pushed into EIP. Okay, now if we take that call, so now we are, what did I do? Did I run, did I step into it, or did I run it actually? I don't know what I did exactly. Let me just repeat this again, sorry. I think I hit F9, but even F9 it should work. It means probably we have a bad character. Let me check again here. Excuse me. So we have these. Sure, I can just do it like this. I know it's not gonna change the bytes itself, but I just gonna do it because I usually do it this way. And it's weird why this didn't work. We will check it out, no problem. So now if I get rid of all of this, okay, let's put the brackets. I like to use it this way. Okay, remove these. So this is our buffer, and this should really work. Why is this not working? Let's check it out. So we have knobs, then the buffer, then this. Yeah, everything should be fine. Let's run it again, and let's do this. So 403, come back here. Sometimes we won't be able to run it in the debugger, so we can test it like so. Call ESI is correct. If we do call, great. Yeah, I think I pressed something by mistake then. So we landed on to where our ESI is pointing to. Okay, you can see ESI is pointing to this area. If you follow on dump, which is where our shellcode is, and now if we run this, we can continue. If you just like skim through the payload, probably this is going to be affecting. So that's why I will test running it. We will see how to find those bad characters and avoid them. I'll have a session just for that. For now, I wanted to introduce those main concepts which I listed over here. So let's just run F9 again, see if anything's going to happen. Yep, all good. I don't know what I pressed the last time. So everything is working fine, all good. Let's probably replace our even our payload with a reverse shell just to make sure we are good. And that's probably what the fancy things about people like to see, which is a reverse shell or a shell on your victim system. So let's do that. Good. And now, so this was working. Great. Let's do create a shell code of, let's see, do I have it over here or no? This is my handler. Let's keep the handler ready. I'm gonna prepare this and I'm gonna create a payload. So these are, by the way, the ASCII. You can see what's a 00, what is 09, 08 that I removed, but we'll get back to those later. Here I will use Windows shell, reverse TCP, localhost 192.168.8.109, local port 443, exit function, architecture, platform, Windows, encoder, shikataganai, minus F the C, minus P the, yep, let's go. So let's get this going. And now I'm gonna rename this or save a copy. Again, I prefer to do it this way. It's all up to your preference. This is not 9, but no problem. Good, so we have this. Let's copy it into our payload. So from here all the way to the end, and so we can have the whole thing. And let's now modify this. So we have, let's remove this. We don't need it. Let's remove this as well. Okay. But there is one thing here that we need to pay attention to. So look at the payload size, by the way, 389. And 389, and if we add to that like the 16 bytes of null no operations, what this means is we no longer have space for our buffer. So you'll need to modify this. Okay, that's why I did this on purpose last time. You'll need to modify this to 10. And as you can see here, you don't need to modify any of your code. The buffer is going to stay here. Just we needed to modify, and this is just one example or one scenario why sometimes you'll need to like lower the number of buffer by the no operations, etc. But you don't need to modify any of this. Everything is going to stay the same. So this time what we will be doing is 389. So we'll add first knobs 10, and then we'll add 389 to that, which means we'll have 399 bytes. So we are going to add at the end of that, we'll have just 1 byte left. So we are going to add the no operation. And then after that, we have our jump or call to ASI. Okay, so let's get this going and let's see everything is good. And let's go back here. The payload, the listener is working. So now we are looking at number 9 because we renamed it by mistake. 403, everything is good. Let's now run the application. And actually, let's run it from outside. Let's run it from outside just because we tested it inside the debugger. Let's test it from here now. FTP client, and now 168.8.109. Hit enter. Something is going on behind the scene, and we can see that we have ipconfig. We have access to our Windows 10 system. We managed to exploit this FTP client. So we did a remote exploitation against a client application. Okay, so that's it for this video. I hope you understood all the concepts that we went over. There are many of them. This is really not just about, let's say, a basic buffer overflow or any of that. It's more about the method of exploitation that we use, that you shouldn't depend always on a jump ESP or a call ESP. Those might not work. You'll need to find other alternatives, and the more you work with this, you'll get better. And it's all really about a lot of assembly stuff. We will add more different techniques while we go through this course. The null byte, we saw how we managed to overcome that in this scenario. By the way, this doesn't mean you will always be able to do this. We were lucky in this scenario, I would say, that we had another register pointing to some of our payload. So we managed to kind of, excuse me, craft the payload which we are sending in a way to avoid the null byte. And then we also saw why a debugger was really important, because if we went the EBP way, the EBP was pointing to the second part of my buffer, which is this one. And we saw once we add the null byte, it got truncated and I no longer know where it is. So we had to go back and go with the ESI way, because it's pointing to another area that I can still control and have access to, and I can still see in my stack, in my debugger. So that's it for this video. I hope it was useful to you. If you have any comments, questions, please let me know. See you in another video. Thank you and bye-bye.